What is the current sensitivity formula? Do you remember that? Pi by I. Pi by I. And then voltage sensitivity is? Voltage sensitivity is pi by V. Those are the two formulas we got, and before that the galvanometer will work based on what I said, magnetic effect. Galvanometer will work based on the magnetic effect, and it will depends on the area of the coil, number of turns, current flowing in that. Why everybody is smiling? You are assuming more. So here it will depend on the magnetic field, current, area, and then don't cry. Don't cry, it's okay, it will happen sometime. So tau is equals to, what is the formula? Bina. Okay, Bina magnetic field, torque will not produced. So that tau is equals to Bina. In that, tau is again, what is the formula in mechanics? C into phi. C is what here? Angular the torsional rigidity. Torsional rigidity or torsional constant, and then phi is the twist, we will take here angular twist, and then here C is the torsional rigidity. Torsional rigidity, and then whenever I equate both, C phi is equals to BINA. From that, current sensitivity is phi by I. This is the formulas, phi by I, and then voltage sensitivity is phi by V. Potentiometer sensitivity is? Potentiometer sensitivity, I said that, reciprocal of potential gradient, L by V. Yes, L by V. Whenever I increase the L value, then what happens? Sensitivity also increases. So only potentiometer will have more length wire. So that is what I said here. Current sensitivity nothing but phi by I. Then phi by I is equals to what we get here? Phi by I is equals to BNA by C. Correct? That is the formula of current sensitivity. Then voltage sensitivity. Voltage sensitivity is pi by V. Pi by voltage nothing but what? Current into resistance only. So that I into Rg is nothing but the resistance of the galvanometer. Now what is this phi by I means? Phi by I is nothing but what? Current sensitivity divided by the resistance only, obviously. So current sensitivity is how much here? BNA by C. BNA by C into Rg. That is the formula of voltage sensitivity and then current sensitivity. And also I said this is completely different topic. Whenever they mention, then only you have to do that. And next whatever we are going to discuss next, it will not at all depends on this one. That is completely different. This is just based on the magnetism topic. Next topics are not based on that. You can get everything easily only. Now before that I said that galvanometer is nothing but it will work based on the magnetic effect. And also even that galvanometer can be converted as ammeter as well as voltmeter by connecting the resistances. And also I said ammeter and then voltmeter about the resistances. Ammeter will have low resistance or high resistance. What is that? I said in the morning. Low resistance. You have to remember that always I is inversely proportional to R. I want to read the current nothing but I should have less resistance. So that only here the current whenever you are converting the galvanometer into ammeter, at that time you have to decrease the resistance. To decrease the resistance, how the resistor should be connected? Parallel combination. Obviously in a parallel combination only R will become how much? R by N. Nothing but it will get decreased. Next, in the case of voltmeter, at that time the resistance should be high. I have to increase the resistance means what I have to do? I have to connect the resistance in series. And mainly moreover you have to mainly remember this one relations between the current and then resistance, voltage and then resistance. High resistance means what they are talking about? High resistance means they are talking about voltmeter. Low resistance means they are talking about ammeter. That you have to mainly identify. And also I said ideal ammeter will have how much resistance? Zero resistance. Ideal voltmeter will have infinite resistance. You have to mainly remember that 2 points are very important for theory. Already it came in the previous year questions also. So ideal ammeter will have zero resistance. Ideal voltmeter will have infinite resistance. By connecting the parallel resistor, galvanometer will be converted to ammeter By connecting the series resistance, it will convert it into voltmeter. Whenever you come to the parallel combination, otherwise parallel resistance, that should be very small resistance should be there. That only is known as what? Shunt resistance here. Small parallel resistor is known as the Mama, you do one thing, you just keep your hand only in the mouth and then pluck like you heard the sound whatever she made. You did not heard Sangeetam ಪೇಪರಾ ಇಲ್ಲ ನಾವು ಇದೇ ನೇಲ್ಸ್ ಏನಾನ ತಿಂತಾ ಇದೀವೇನೋ ಅಷ್ಟು ಸೌಂಡ್ ಮಾಡ್ತಾ ಇದ್ವಿ ಅನ್ಕೊಂಡೆ. ಲೈಕ್ ದಿಸ್ ಶಿ ಕೇಪ್ ಲೈಕ್ ದಿಸ್ ಅಂಡ್ ದೆನ್ ಶಿ ಪ್ಲಕ್. No, you do one thing na, just a plucker ಅದರ ಕಟಿಂಗ್ ಬ್ಲೇಡ್ and then you just pluck it. ವಿಚಿತ್ರ ಮಾಡ್ತಾರಮ್ಮ. ಏನು ಮಾಡಿದ್ರೆ ಏನೋ ನಮಗೆ ನೆನಪಿಲ್ಲ. So here whenever you are converting the galvanometer into ammeter, nothing but you have to connect a shunt resistance. Shunt resistance nothing but parallel small resistance. And then to convert into voltmeter, we should connect a high resistance in which combination? Series combination. Clear? That is about the basic knowledge about the voltmeter and then ammeter. After connecting and all, we will get the ranges. What is the old range and then what is the new range and all we will discuss. Right, first introduction you write. First this one you write. Yes, Gundi Chopra will work based on నీకే నవ్వు వస్తుందా? నవ్వు రావాలనే కదరా చెప్పేది. Gundi Chopra will work based on magnetic effect of current in the coil. Magnetic effect of current in the coil. Write that. Write current sensitivity and then voltage sensitivity and all. Finish the voltage sensitivity and then current sensitivity. Then write in the next line, the galvanometer can be converted. Galvanometer can be converted as ammeter and voltmeter. As ammeter and voltmeter by connecting a small resistance in parallel, a small resistance in parallel in bracket shunt resistance. A small resistance in parallel in bracket shunt and a large resistance in series. And a large resistance in series. In the next line, ammeter should have less resistance. Ammeter should have less resistance. Ammeter should have less resistance. Whereas voltmeter should have high resistance. Voltmeter should have high resistance. In the next line, note point, very, very important. Very, very important. Ideal ammeter will have zero resistance. Ideal ammeter will have zero resistance. In the next line, ideal voltmeter will have infinite resistance. Ideal voltmeter will have infinite resistance. Ideal voltmeter will have infinite resistance. Now, let's discuss the conversion of galvanometer to ammeter. Conversion of galvanometer into ammeter. How we can convert that into ammeter? By connecting a shunt resistance. That should be very smaller value. And now, here if we consider without ammeter, first of all we are not converting any ammeter, we are just taking the initial only. Initially who is there? Only galvanometer coil is there. Whenever I connect the shunt resistance, then only it is becoming as a ammeter. First of all, I have taken the galvanometer only. Initial value is galvanometer only. So that galvanometer coil, in that the current flow is how much? Ig, and then resistance is how much here? Rg. Now, let me take, I have taken 2 points here, A and B. What is the potential difference between A and B? What I can write? VA, we are going in this direction, minus Ig Rg is equals to where you are reaching? VB. So, simply VA minus VB is equals to what I can write? Ig into Rg. Now, this is the potential. Old or new na? Old. V old. V old. What people will think? Not V old, you old, like that you will be thinking. Correct? Shreyash? V old andre naಮಗೆ ಯಾಕೆ old ಅಂತ ಇದ್ರೆ ನಾವು still youth teenagers ಅಂತ ಅನ್ಕೊಂತ ಇದ್ದೆ ನೀವು. V old is ಏನು? ಅಂಕಲಾ? ಏನು ಪ್ರಮೋದ್ ಚೋಪ್ರಾ ನಿಮಗೆ ಅಂಕಲ್ ಆಗ್ತಾರೇನೋ ಅವರು? Okay, PC uncle, PC auntie and then SC uncle. Right here, this is the old range. GC child. So V is equals to Ig into Rg. So whatever, whenever you see the galvanometer problem, you will remember all these jokes and then you will not remember the formulas. I know that. Correct? That is what will happen in the exam also. So V is equals to Ig into Rg. This is a old range. Why? Because nobody is there. Only galvanometer is there here. Yes. Now I want to convert to ammeter, nothing but what I have to do, obviously. What we have to do for the Gundi Dhanush here? We have to connect a shunt resistance. Then GC will become as what here? Sina? Sina, Sheena? Sheena. Now here galvanometer I have taken. For that we are connecting a shunt resistance here. Now this one is becoming as what here? Ammeter. This one was old and then this is a new now. In that current flow is how much is there? I. In that current Ig is going for the galvanometer. Then remain current how much is going? I minus Ig is going for the shunt resistance. Now here also you have to again find out the VA and then VB. So let us take at this point. There is no need to find VA, VB also, it will come directly. Let me take, I will apply the KVL for this loop. Whenever I apply the KVL for this loop, at this point I have started, at this point exactly. Whenever I start at this point, here there is a current flow in the resistance. So that what will get here? Minus Rs into I minus Ig, correct? Minus I into R. Now you are going into the galvanometer coil. Even this is also resistor only indirectly. Now in that how much current is flowing? Ig current is flowing. So that what you have to take? Plus or minus? Plus. I am going in this way, current is coming opposite to me. So that what I can say, plus Ig into Rg, that is equals to how much here? 0 obviously. Then Ig Rg is equals to what I can write? Rs into I minus Ig. This is a new range of the values now. In this, mainly for the problem solving, Ig nothing but what? Old or new na? Old, only galvanometer was there, so that is a old range we will take. And then here I is the new range. After connecting the shunt resistance, I am getting the new current. So that is a new range. This is a new range. For the problem solving, it is very, very important. In this, only two formulas will be there. But the terminology is very important, that will only confuse you. So terminology is very, very important in this. Each and every terminology, whatever I am using here, you have to remember that. So here the old range nothing but only, okay, in the old circuit only galvanometer was there. So only Ig is the old range. Now in the new circuit, I have connected some shunt resistance, so that only I am getting the new current as how much? Nothing but I is the new current, so that here I is the new range of the value. Now this Ig Rg indirectly what I can write here? V I can write, so that V is equals to Rs into I minus Ig. Up to here also we can stop, and then we can say this is Ig Rg is equals to Rs into I minus Ig. Clear? That is about the ammeter, and also the range value will be there. If you are have to increase n times, nothing but what is that n value should be, otherwise what is the shunt resistance should be and all. Clear? So first of all, whenever you are converting the galvanometer into ammeter, at that time initially only who is there? Galvanometer was there. After connecting the shunt resistance, what I am converting it as? Ammeter. So that ammeter is a new value, and then only galvanometer what is the old value, with resistance, without resistance. Without resistance old, with resistance that is new. Now I have taken the galvanometer coil. This is just like a resistance only. You just consider that as a resistor only. So this is a galvanometer coil of resistance how much? Rg. Current flowing in that is how much? Ig. Potential is equals to what is the formula? I into R only. How much current is flowing? Ig. Resistance is Rg. So that Ig into Rg. V is equals to Ig into Rg I have written. Then after that, now you are converting into ammeter by connecting a parallel resistance. So that I have connected a parallel resistance here. Shunt resistance I have taken. Rs means shunt. So shunt resistance I have taken. At that time current value will changes. Why? Because I am decreasing the resistance value here, so that the current flowing in the circuit is how much? Nothing but I with resistance. Now that is splitting as Ig and then I minus Ig we can take. Otherwise you can take this as I dash also. Finally I dash is how much again? I minus Ig only. So I minus Ig is the current flowing in this, remaining current Ig is current gone in the galvanometer. Now you have to apply the KVL here. So what will you get here? You are going in the direction of current, so that minus I minus Ig into Rs, and going opposite to the current for the Rg, so that what I can write? Plus Ig into Rg. From that Ig into Rg is equals to Rs into I minus Ig. Here who is new? Nothing but I is the new. Why? What we have done that? We have converted into ammeter, that is a new value here, new range, and then Ig is the old range. Clear? Yes, copy that. Next, write a problem. Resistance of a galvanometer is G. Resistance of a galvanometer is G. To increase its current range, n times of initial value, then find required value of shunt resistance. Get the answer. ಉದಯ ಎಲ್ಲಿ ಹೋಗಿದ್ದಾನೆ? ಯಾಕೆ ఏమైందంట? జ్వరం వస్తుందా? వాడి కోల్డ్ ఎక్కువ కదా కొంచెము. ಏನು ಗುಸುಗುಸು? ಪ್ರಮೋದ್ ಚೋಪ್ರಾ ಆ್ಯಂಡ್ ಶ್ರೇಯಸ್ ಚೋಪ್ರಾ ಸೀಕ್ರೆಟ್ಸ್ ಪ್ರೈವಸಿ ಬೇಕಾ ನಿಮ್ಗೆ? ಏನಾನ ಪ್ರೈವಸಿ ಬೇಕಂದರೆ ಹೇಳ್ರಿ, ನಾವೆಲ್ಲರೂ ಹೊರಗಡೆ ಹೋಗ್ತೀವಿ, ಇಲ್ಲಾಂದರೆ ನಿಮ್ಮನ್ನೇ ಮೇಲೆ ಕಳಿಸ್ತೀವಿ ಟೆರ್ರಸ್ಗೆ. You got that? G by? Yes, very good. G by n minus 1. G by n minus 1 is the correct answer. Here I am saying that, see that this formula only, based on this only you will get the answer. Here Ig Rg is equals to, you have to find out the shunt resistance, by the way. Rs value you have to find out. For that, here Ig Rg is equals to, we have Rs into I minus Ig. Who is the new value here? I is a new value. What you are doing for the I now in the problem? N times we are increasing. So that Ig is as it is, Ig Rg. But what I said nothing but the new value is n times of old value. New value means what? I. N into I old nothing but what here? Ig only. So in the place of I you have to substitute n into Ig minus Ig. Ig gets cancelled both the sides. Then what is remaining for us? Rs is equals to what I can say? Rg by n minus 1. Otherwise Rs is equals to G by n minus 1. Very important formula. Very important formula. G by n minus 1. Next conversion is galvanometer to voltmeter. Galvanometer to voltmeter. Galvanometer to voltmeter. So already volt range is same, there is no change in that. Previously what will be there here? Only galvanometer will be there. So that we have find the voltage also. V is equals to Ig into Rg. Now I have to convert into voltmeter, means what you have to do basically? In series you have to connect a resistance. That should be high resistance or low resistance? High resistance. You have to increase the value number of times, nothing but you should connect the high resistance only. So that only I am taking it as a RH, high resistance. Now this is already having how much resistance? Rg. Now current flowing is how much here? Ig. Series combination, no? So everything is same current, there is no change in that. Now here the points I will take, this is a point A and then point B. Now tell me, VA, what will you get first? VA minus Ig into Rg minus Ig into RH is equals to what? VB. Clear? We have taken from A to B, all the potentials we have written. So here VA minus IgRg minus Ig into RH, that is equals to Vb. Now Va minus Vb is equals to what I can say? Ig into Rg plus RH. What is the Va minus Vb means? Va minus Vb means already how much? Vg into Rg. So that is Vg Rg is equals to, Ig into Rg is equals to Ig into Rg plus RH. Everything we cancel means nothing will be there. Yeah, this is a old range. Directly there is no need to cancel anything. Directly we will take it as a old range, and then this is the new range. Understand? So there is no need to equate also. First of all, mainly you have to identify which is the old one, which is the new one. Old one nothing but in that only galvanometer resistance, galvanometer current will be there. New one means in that which is included here, series resistance will be included, that is a high resistance here. So that old range is equals to new range. Here what they will say means it will be n times of the old range, like that. New range is n times of the old range, like that they will tell. So that there you can substitute, you don't write this one, otherwise you will get confused that. Directly you write this only. So here Va minus Vb, this one is which one? New range na? V new is equals to Ig into Rg plus RH. This is what here? V old. V old is equals to Ig into Rg. V new is equals to Ig into Rg plus RH. Clear? So here when you take it as a new, nothing but whenever you are connecting the extra resistance, that might be Rs or RH, whatever it might be, we are getting the extra value means that is a new value. So we are getting only galvanometer values, nothing but that is a old value here. So this is about that old range of the voltmeter and then a new range of the voltmeter. Whenever there is no resistor here there is a series high resistance is there. Listen again. So here we are converting the galvanometer into voltmeter by connecting a high series resistance value. So for that, before connecting we are having only galvanometer coil of resistance is how much? Rg. Current flowing is how much? Ig. Now voltage is how much here? Voltage equals to Ig into Rg. Here nobody is there, so that is a volt range here. So V volt is equals to Ig into Rg. Then after that, I want to convert into voltmeter means I have to connect extra resistance here. By that again Va minus IgRg minus IgRh is equals to how much? Vb. Why? Because in the same current is flowing in this, which combination that is? A series combination. Before we have taken Ig and then I minus Ig. What is the reason? That is a parallel combination, current will be different in both the terms. So here Va minus Vb is equals to Ig into Rg plus Rh. Then Va minus Vb nothing but what? New voltage, so that V new is equals to Ig into Rg plus Rh. Now in the problem what they will tell, nothing but we have to increase the present value as n times of the previous value. Nothing but in the place of V new what will substitute? N times of V old will substitute. Then we will get the RH value. Clear? Old nothing but V old, what is the formula? Ig into Rg only. Ig gets cancelled, you will get the answer there easily. Clear? Yes, copy first. ఏమో పెన్ను కావాలా? ಎರೇಜರು, ಶಾರ್ಪ್ನರು, ಪೆನ್ನು, ಸ್ಕೇಲು, ರೌಂಡರು ಏನಂತಾರಮ್ಮ, ಮತ್ತು ಏನೇನೋ ಜಿಯೋಮೆಟ್ರಿ ಬಾಕ್ಸ್ ಎಲ್ಲ ತೊಗೊಂಬಮ್ಮ ನೀವು. ಕಾಲೇಜಲ್ಲಿ ಮಾರ್ಕರ್ಸ್ ಏನೇನು ಆಗ್ತಾಯಿದ್ವು ಅಂದರೆ ಅದು ಕೇವಲ ಬಿಕಾಸ್ ಆಫ್ ಯು ಓನ್ಲಿ. ಕಾಲೇಜ್ ಪ್ರಾಪರ್ಟಿನ ನೀವು ಇದು ಮಾಡ್ತಾಯಿದ್ವಿ. ಮೊಯ್ನ್ ಸರ್ ಹೊಸ ತಗೊಂಬರ್ತಾರೆ, ನೀವು ಡೈಲಿ ಒಂದು ಹಾಳು ಮಾಡ್ತೀವ ಏನು? ಅಕ್ಷತಾ, ಹೌ ಮೆನಿ ಅವರ್ ಚಾಕ್ಲೇಟ್ಸ್ ಯು ಈಟ್? ವಿಲ್ ಬಿ ಲೈಕ್ ದ್ಯಾಟ್ ಓನ್ಲಿ. ಚಾಕ್ಲೇಟ್ ತಿಂದಿವಲ್ಲ? ಡೋಂಟ್ ಲೈ. ನಮ್ರತ ತಿನ್ನಿಂದ లేదా? ತಿನ್ನಿಂದಿ ಚಾಕ್ಲೇಟ್, ಐ ಹ್ಯಾವ್ ಸೀನ್ ಯು. ಬ್ಯಾಗಲ್ಲಿ ಬ್ಯಾಕ್ ಸೈಡ್ ಇತ್ತು, ಚಾಕ್ಲೇಟ್ ತೊಗೊಂಡು ತಿಂದ್ರಲ್ಲ. రైట్, నెక్స్ట్ ప్రాబ్లం చెప్పరా ఫోన్ లేదు, ఫోన్ తీసుకొని. రెసిస్టెన్స్ ఆఫ్ ఎ గ్యాల్వనోమీటర్ ఈజ్ G. Resistance of a galvanometer is G. To increase its range, n times of its previous range, then find the series resistance required. Find the series resistance required. Find the answer. Yes, G into n minus 1 only, you prove that. G into n minus 1 is the correct answer. G into n minus 1 is the correct answer. Yes, you got that. G into n minus 1. You got that? Yes. See that V nu is equals to Ig into Rg plus Rh. Now what I am saying, the new range is how many times of old range? N times of old range. Then Ig into Rg plus Rh. Now n into, what is the V volt value? V volt is equals to Ig into Rg. Ig Rg is equals to Ig into Rg plus Rh. Then Ig gets cancelled here. What you have to find out? Rh value, no? Rh is equals to what I can write? G by n minus 1. Rg by n minus 1, then G by n minus 1. I said one shortcut to remember these formulas. What I said? G into n minus 1. Yes, yes. I said one shortcut to remember this. What is that I said? What is I said? You have to, no, this is a series, ammeter nothing but what you have to take? Less resistance or more resistance? Less resistance. Less resistance nothing but divide by n minus 1. Voltmeter nothing but you have to take high resistance, you have to increase the resistance, means what you have to do? You have to multiply with n minus 1. Clear? Write that short trick to remember conversions. Required shunt resistance. Ammeter will have less resistance. Ammeter will have less resistance. To decrease the resistance, divide G with n minus 1. Divide G with n minus 1. In the next line, for finding the series resistance, voltmeter will have high resistance. So multiply G with n minus 1. Write that RS is equals to G by n minus 1. RH is equals to G into n minus 1. RH is equals to G into n minus 1. Very, very important. Most of the students will get confused here only. Instead of taking G by n minus 1, they will take G into n minus 1, then you will get the wrong answer there. So you have to mainly make that as important. And now here RS nothing but what here? Shunt resistance. What is the formula I said? G by n minus 1. Here n nothing but what? The increment of the new value as compared to the old value. For example, they have given new value as 150, old value as 15. Now how many times n is equals to how much? 10. 150 is a new value I said. 15 is the old value, means n value is how much? 10. They will not mention always 10 times it is increasing like that. They will give the voltages only directly. You have to identify that. Even in the currents also same only. So here RS is equals to G by n minus 1 and RH nothing but high resistance. In the case of voltmeter, RH is equals to what I said? G into n minus 1. In the ammeter we have to decrease the resistance, so only dividing. In voltmeter you have to increase the resistance, so only I am multiplying here. That is how you remember the formulas. Okay, write the problem now. The value of RG is 30 ohms. The value of RG is 30 ohms and its current range is 1 milliamperes. Its current range is 1 milliamperes. To read maximum 30 volts, with this meter, then find required series resistance. Required series resistance you have to identify. And by the way, in this galvanometer and then even in the current electricity chapter, you should not take any approximate values. You have to take exact values always. In this 9999 like that also it will be there in this galvanometer concept, so that you should not take approximate. The answer will get, I think, 29,970, I guess so. Is that correct? Yes, sir. Terminology is very important in this. అరే నిన్ను కొట్టి నాకు వేలు ఫింగర్ నొప్పి వస్తుంది. See the question. The value of RG is how much they are saying? RG is equals to 30 ohms. RG is equals to 30 ohms and after that, and its current range is 1 milliampere. So that what they have given? RG is given, its current range means what is that? IG. Okay, and also you write one more point for the IG. IG nothing but the current range also they will say, and then current drawn by the galvanometer. Current drawn by the galvanometer or current range, and also one more very important will be there, that is full scale deflection. Full scale deflection. Those are the terminologies which will be used for the IG. Clear? So that current range how much they are saying? IG is equals to 1 milliampere. 1 milliampere, that is 10 power minus 3 amperes. And after that, what they are saying? 1 milliampere. To read the maximum value 30 volts means which is reading here? Which device is reading? Voltmeter. 30 volts we are reading nothing but voltage we are reading means we are using which device? Voltmeter here. So that the voltmeter V is equals to 30 volts. We are reading means that is a new range of old range. New range. Remember all these terminologies are very very important. We are reading at present. At present nothing but that is a new range. So that V new is equals to 30 volts. That is what given. Then after that you have to find out the RH. For that what is the formula? V new is equals to Ig into R plus Rg plus RH. V new is equals to Ig into Rg plus RH. Now new is how much here? Value is 30. Ig is how much? 10 power minus 3. Rg is 30 plus RH I have to find out. Then this will be how much here? 30,000 minus 30 gives you the RH value. The RH is 29,970. Don't go for the approximate values. I am saying again and again in this entire chapter, not only this concept, entire current electricity, you don't take any approximate values. Finished? How many of you got that correct answer? Raise your hands. Yes, good, very good, very good. The next problem. The voltage range of a meter is 10 volts. The voltage range of a meter is 10 volts. Its resistance is 10 ohms. Voltage range of a meter is 10 volts. Its resistance is 10 ohms. Meter means obviously which meter they have given about? Galvanometer. That's it. Galvanometer. They are not mentioned anything means that is simply galvanometer only. Its resistance is 10 ohms. To increase otherwise to read 100 volts with this meter, to read 100 volts with this meter, then calculate the value of additional series resistance. Calculate the additional value of series resistance. How much? Very good, Nana. Read the question properly and get the answer. $90 is the correct answer. Yes, you got that? 90 ohms is the correct answer. Shall I? See that? The voltage range of a meter, just they have given about the measuring device or a meter, otherwise a scale means that is they are talking about only galvanometer. Without mentioning anything, just they are telling that the voltage range of a meter means that is a galvanometer first of all. So the voltage range of the galvanometer is 10 volts. Nothing but which range that is? Old range or new range? Old range, only galvanometer they are talking about. So that V old is equals to 10 volts. Its resistance is how much here? 10 ohms. So that what they are talking about? Rg is equals to 10 ohms. Then after that, to read the value as how much? 100 volts. So that new value is how much here? V new is equals to 100 volts. Then you have to find out the additional resistance RH. I will tell you in very shortcut method and then I will tell you in the normal method, this one. So whenever you see the problem, immediately you try to find out the n value. Then only it will be easy for us. So here, old range is how much? 10 volts. New range is how much? 100. Nothing but how many times it is increasing? 10 times. That's it, finished. So n is equals to, what is the formula for us? N is equals to 10 and then RH is equals to G into n minus 1. So here V new is equals to N times of V volt. V new is how much they have given? 100 is equals to N times of V volt is how much? 10. Then N is equals to how much here? 10. N is equals to 10. Then after that, RH is equals to direct formula. RH is equals to RG into RG is how much here? 10 into 10 minus 1, nothing but how much it will give us? 90 ohms is the correct answer. Otherwise, I can take V new is equals to, what is our usual formula? V new is equals to IG into RG plus RH. The new range is how much here? 100. And then I don't know the IG value. I is equals to, what is the formula? V by R only. So that V volt by RG. I is equals to V by R is the formula. So that V volt by RG into RG plus RH. Then here 100 is equals to V volt is how much? 10 divided by RG is how much? 10. And then this is 10 plus RH. Again same answer only. RH is equals to how much? 90 ohms. Clear? How many of you got that correctly? Very good. Remaining people you have to do still. Try for that. 2 methods. You can get the answer in any way. Next problem. Do it fast. RG is equals to 100 ohms. RG is equals to 100 ohms. And its current range is 10 power minus 5 amperes. 10 power minus 5 amperes. If we want to read 1 ampere with this, meter, then find approximate value of shunt resistance. Approximate value of shunt resistance. Do it faster. Then పోయి డ్రాప్ చేయపో నాన్న బోర్డ్ డ్రాప్ చేయపో. Approximately you have to get the answer 10 power minus 3. Yes, 10 power minus 3 is the correct answer. Approximately you get 1 minus 10 power 5, I guess so. You take it as 10 power 5 only. 10 power 5 minus 1, I guess so you will get. Take it as 10 power 5 only. 10 power minus 3 is the correct answer here. Listen. RG is how much here? RG is 100 ohms. Then, and its current range is how much they are saying? Current range nothing but what you have to take? IG. Yes, IG is the current range, right? Generally IG, I said IG nothing but is also known as the current range. So that IG is equals to 10 power minus 5 amperes. Then after that, we want to read 1 ampere with this meter. We are reading means which value that is? Old value na new value na? New value. So that I knew is equals to how much I said? 1 ampere. I knew nothing but what we will take it as? I only in the formula. Then after that you have to find out the approximate value of shunt resistance. To find out the shunt resistance, we already know that what is the formula we got? I minus Ig into Rs is equals to what is the formula? Ig into Rg. This is the formula for the ammeter conversion. Now I is the new value here. New is how much here? 1 ampere. Minus Ig is how much? 10 power minus 5 into Rs you have to find out, that is equals to Ig is 10 power minus 5 again. and Rg is how much here? 100. This will be how much here? 10 power minus 3, and then 1 minus 10 power minus 5 means that is negligible value. Why? Because I mentioned in the question that is approximately. If not, you have to take as it is, that is 0.49, I guess you will get. So you have to take as it is. Now approximately, so that this is negligible. Then here Rs is equals to directly what is the answer? 10 power minus 3. And also in terms of n also we can get the answer. So I volt is how much here? I volt, Ig is equals to how much? 10 power minus 5. I nu is equals to how much? 1 ampere. So that what I can write here? I nu is equals to n times of I volt. Correct? N times of I volt. Now I nu is how much here? 1 ampere, and then n into I volt is how much? 10 power minus 5. Then n is equals to how much? 10 power 5. You no need to do this much also. By seeing itself you can say that. Okay, for the explaining I am just writing this much. No need to do that much. By seeing itself only you can say that I nu is equals to 1 ampere, I volt is 10 power minus 5 means n value will be how much? Nothing but 10 power 5 will be there. Now I know already Rs formula. Rs is equals to what is the formula? G by n minus 1. G value is how much? 100. That divided by n is 10 power 5 minus 1. In front of 10 power 5 nothing but you will get 1 lakh. Yes, in front of 1 lakh 1 is negligible. Why? Because I am saying it as approximate. If not, you have to take 99,999. Okay, compulsory you have to take that. Now this will be how much? Obviously 10 power minus 3 again. Same answer. Clear? Right. Next problem. This one is little twisted question. Write that Rg is equals to 10 ohms. Rg is equals to 10 ohms. Number of divisions in the scale of meter is, number of divisions in the scale of meter is 50. Number of divisions are 50 simply. Number of divisions in the scale of meter is 50. I said scale means what you have to take? Gallanometer. Okay. So, and 1 ampere current is, required for the deflection of one division, we want to read 1 kilovolt with this meter. Then find the value of series resistance. Read the question properly. Entire answer is there within first one line only. ಅದು ದೇರ್ ಗಿರೀಶ್ ಮೇಡಮ್ ಏನೋ ಚೆಕ್ ಮಾಡ್ತಾಯಿದ್ರು, ನಮಗೆ ಚೆಕ್ ಮಾಡ್ತಾಯಿದ್ದೀವ ನೀವು? How much? 10. Yes, I think it's correct. Yes, very good Drishti. 10 ohms is the correct answer. Read the question properly first. First line is very important. Simply you have to mainly identify Ig value. How much Ig value is? 50 amperes. Then you got the answer. 10 is the correct answer. Yes, good. Ig is 50. That is what they have given indirectly. Yes, good. See that. See the question. They are saying that Rg is equals to how much? Directly I said 10 ohms. Rg is 10 ohms directly I said. Okay, then after that, the number of divisions in the scale. I said anything they have given scale or measuring device or meter means directly they are talking about the galvanometer. Okay, now that you have to mainly remember. So you have to even, you can write at the side also in the notes. So the number of divisions in the scale of the meter is how much? 50. So that here number of divisions is 50, and after that 1 ampere current is required for one deflection. So that for one deflection 1 ampere nothing but for the one deflection 1 ampere. How many divisions are there for us? 50 divisions. 1 division 1 ampere, 50 divisions 50 amperes. That's it. Full scale deflection. So only I said Ig nothing but full scale deflection also they will say. So that 1 division is 1 ampere, then 50 divisions is equals to what I can say? 50 amperes. That's it, finished. This is the Ig value. That is a full scale deflection. Full scale deflection. You don't know that kind of terminology, so only I mentioned before only. Ig nothing but we can say current drawn by the galvanometer, current flowing in the galvanometer, otherwise full scale deflection, and also range also. Range of the scale, range of the meter, or range of the galvanometer, or range of the measuring device, whatever it might be, everything they are talking about the Ig only. So here Ig is the 50 amperes. Then obviously what they are asking here? Shunt resistance or series resistance? Series resistance. So what they have given after that? Next. If you want to read 1 kilovolt, okay, 1 kilovolt V nu is equals to, what is the formula? Ig into Rg plus Rh. We are reading nothing but that is which range? New range. So that new range is 1 kilovolt, 1000 is equals to Ig is 50, Rg is how much? 10 plus Rh. Then Rh is equals to automatically how much? This will be 20 times, and then Rh is equals to 10. That's the correct answer. How many of you got that before me? Raise your hands. Yes, almost. Very good. Very good. Back side ನೋಡೋದಿಲ್ಲ, ನೀವು ಕೂಡ ಕೈ ಎತ್ತಬೇಕು. Right ಅಲ್ಲ? Right, last problem. It's okay. ಪ್ರಾಬ್ಲಮ್ ಇದು ಕೊಟ್ಟು ಬಿಡ್ತೀನಿ, ಆಮೇಲೆ ಮಾಡ್ಕೊರಿ ಬೇಕಂದ್ರೆ ನೀವು. Resistance of a galvanometer is G. Resistance of a galvanometer is G. It is shunted by a resistance S. It is shunted by a resistance S. A series resistance is connected with this meter. Connected with this meter. Then what should be the value of series resistance? Then what should be the value of series resistance? So main current in the meter remains same. Main current in the meter remains same. Nothing but before everything we have discussed about either only parallel or only series. Now I just combined them. Now I am saying that the new current whatever we are getting is same as the old current. That is the question. Then what should be our R dash value here? One is parallel, another is series. R dash value you have to identify. Ab jayama video.